For the function y is equal to kx to the n, where k and n are like constants which can be real numbers, determine an expression for the gradient function. So in the previous video we looked at trying to find what we meant by the gradient function, and when we did y was equal to x squared, we found that the gradient function, which we write as dy by dx, was 2x. Now you can get to 2x by doing the following. Taking the 2, bring it down in front, writing down x, and then reducing the power by 1. So just repeat that. Take the power down in front, write down x, and then reduce the power by 1. That will give you 2x. So if you did like y is equal to x cubed, then dy by dx would be bring the power down, 3, write down x, and then reduce the power by 1, which will give you 3x squared. If we did something like y is equal to x to the 4th, then we bring down the 4, so bring down the 4, write down x, and then reduce the power by 1, which gives you 4x cubed. Now what happens if you had something like 3x to the power of 5? Well, you do the same process. Dy by dx will be equal, you bring the 5 down, but instead now you write down 3x, but you reduce the power of the x by 1. And then that becomes 5 times 3, which is 15, x to the 5 minus 1, which is 4. Now, going back to the first one, which is y is equal to x to the 1, well, we know the gradient of that line is actually equal to 1. But does this process work? Well, we've got dy by dx, so it means bring down the 1, write down x, and then reduce the power by 1. So that becomes x 1 times x to the 0, which we write as x to the 0, and we know anything to the power of 0 is equal to 1. So that does actually work for things like y is equal to x. So the general rule is if y is equal to kx to the n, i.e. k in this case would have been 3 and n would have been 5, then dy by dx means bring down the power, so bring down n, multiply by kx, and then reduce the power by 1. So that's normally written as nkx to the n minus 1. Okay, so this has been a video for you to show you how to determine the expression for the gradient function. The bottom one here needs to be learnt. I hope you've understood. Before we carry on, this process of doing this, going from this to this to this, is called differentiation. Okay, I hope you've understood, and I thank you very much for watching.